Okay, so we're going to look at simultaneous equations now, and this is a bit of a complex topic in that you can mix up things like exponentials, the things you see over here, and even coordinate geometry and things like that. But it's a really fun topic, so let's go straight into it. So our first question is a simple solve the simultaneous equations kind of question. So let me just go ahead and get my pen here. But the thing is, it's masked within an exponential. So the first thing you see when you look at these two equations is, well, how can I get the x and y at the bottom so that I can, do my normal algebra kind of thing and kind of get an answer with x and y. The first thing you might see is we've got 125 to the power of x, 25 to the power of x, and 5 to the power of y. And over here we have 7 to the power of x, 49 to the power of y, and 1. So let's just go ahead and write those down real quick. So let's say that's equation 1, which is 125 to the power of x is equal to 25 times 5 to the power of y. Cool. So what do you notice about 125, 25, and y? Well, that's 5 cubed, that's 5 squared, and that's just 5 to the power of 1, if you will. So let's rewrite that. Let's say 5 cubed to the power of x is equal to 5 squared times 5 to the power of y. And if you guys know your exponential rules, then we can just multiply these two together and add these two together. So 5 to the power of 3x is 5 to the power of 2 plus y. Cool. And since we have the same base on both sides, what we can go ahead and do is just consider our powers. So 3x is going to be equal to 2 plus y. And we're done with equation 1. So let's go ahead and do the same thing for equation 2 now. We have 7 to the power of x divided by 49 to the power of y, which is equal to 1. Okay, so again, 7 squared is 49, so let's rewrite that. Let's say 7 to the power of x divided by 7 squared to the power of y is going to be equal to 1. And what do you know about 1? So we know that any number to the power of 0 is going to be equal to 1. So since we're considering 7s here, why don't we go ahead and rewrite 1 as 7 to the power of 0. So if we just use our log rules, exponential rules, we can say that, which is completely true, of course. And then if we once again use our exponential rules, we can say that 7 to the power of x minus 2y is equal to 7 to the power of 0. So naturally x minus 2y is equal to 0 itself. Cool. So what do we know about simultaneous equations? The most basic thing. Well, we know that when these two curves intersect, they're going to have the same x and y coordinates, which means the first curve can be set equal to the second curve. And we've got two equations we can now work with. So let's go ahead and first write x is equal to 2y. Let's just move the y to the other side. And this is great because what we can do is just go ahead and substitute that into this, giving us 3 times 2y is going to be equal to 2 plus y. Cool. And if we just go ahead and solve that, 6y is also going to be equal to 2 plus y. Move the y to the side, so 5y is equal to 2, and naturally y is going to be equal to 2/5. Cool. Now one thing to remember every single time when you're doing simultaneous equations is that you're not done when you find one variable. We still have to find our x. So how do we do that? Well, we know x is equal to 2y and we have our y. So what we can go ahead and just do is x is equal to 2 multiplied by 2/5 which gives us 4 over 5. And that's it. That's the solution of our simultaneous equations. Y is 2/5 and x is 4/5. Cool. Now the next question is actually pretty straightforward. It's asking us to find the intersection of y is equal to 2x minus 3 and x squared plus y squared plus xy plus x is equal to 30. Yeah, this one's a bit of a complicated equation, but that's the good thing about simultaneous equations. You don't have to actually think about what the curve looks like, because you know that at the intersection point they're going to have the same x coordinates and the same y coordinates. And actually this question does us a huge favor by just giving us y is equal to 2x minus 3 as our first equation. And even though our second equation is super complicated, solving this shouldn't be a huge issue. So let's go ahead and say, like we did before, that that's our equation 1 and that's equation 2. Since we already have our y and x separately over here, let's go ahead and substitute this straight into this. So how do we do that? We say x squared plus, now here's our y, this whole thing is now y, so let's say 2x minus 3 all squared plus x multiplied by 2x minus 3 plus x is equal to 30. This whole thing is equal to 30. Cool. So let's go ahead and do some of this expansion. So that's going to be 4x squared minus 12x plus 9 plus 2x squared minus 3x plus x is equal to 30. Excellent. And this is a pretty standard quadratic. We've got our x squared terms, we've got our x terms, and our constant terms. So let's just make it a little bit neater to look at first. So we just combine our x squared terms, we get 7x squared. If we combine our x terms, it's minus 12 minus 3 plus 1, so minus 14x, and 9 take away 30 is negative 21. Cool. We can just divide by 7 on both sides and we'll get x squared minus 2x minus 3 is 0. And this is a beautiful equation because we can just go right ahead and factor this and get x plus 3, x minus 1. Oh wait, excuse me. That should not be that. That should be x minus 3 and x plus 1 is equal to 0. Cool. And we know that since we have these two, we can just go ahead and say x is equal to 3 or x is equal to negative 1. Now remember that we're not done there because we still have to find our y values. But the good thing here is we already know that y is 2x minus 3. So if we just plug this straight in, we have 2 times 3 minus 3, which is just 3. 2 times minus 1 minus 3, which is minus 2 minus 3, which is negative 5. Phew. And that's our answer. And if you want to make sure that you get full marks for this question, since it's asking for the coordinates, let's just go ahead and list them as coordinates. So let's say 3, 3, negative 1, negative 5. And we're done. It's actually not too hard. So let's look at the last question now, which is asking us for a midpoint. Okay, so this is a bit new. We've got a line, we've got a curve, and we want the midpoint. So let's just write down what our two equations are. So x plus y is 10 and y squared is 2x plus 4. Cool. Let's say that's 1, let's say that's 2. And for a question like this, the first thing you might want to do is just draw yourself a pretty simple graph. So if this is y squared is 2x plus 4, we can just say that y squared minus 4 over 2 is equal to x. And that's the same as saying half y squared minus 2 is equal to x. And you don't have to know exactly how this looks, but a rough sketch is going to be something like this. Since it's a parabola, but then on the y side instead of on the x side, so it's kind of a twisted quadratic. And for this, well, this is just going to be y is equal to minus x plus 10, which is going to look a little bit like that, something like that. Of course, these two are going to intersect again, so let me just there we go. Cool. And let's go ahead and say that's a yep, that's a, and that's b. So what do we want? We want the midpoint of AB, so that's going to be somewhere over here maybe. And how do we go about finding that? Well, obviously the first thing we want to do is intersect these two lines. So let's go ahead and do that. We just found out that y is minus x plus 10, so we can just go straight ahead and substitute that into this. But actually something that might be easier to do is say, so let's instead say that x is equal to 10 minus y, which is just a rearrangement of this equation here. And why do we want to do that? Well, we know that y squared is 2x plus 4, so we know we can just substitute this straight into the x. And what that does is kind of saves us some time, since we don't have to square out everything. So we say y squared is 2 times 10 minus y plus 4. So y squared is going to be 20 minus 2y plus 4. So y squared plus 2y minus 24 is going to be equal to 0. And so how are we going to factor this out? We want something that gives a sum of 2 and a product of negative 24. So we can't have 3 and 8, we can't have 12 and 2, but we can have 6 and 4. So y plus 6, y minus 4, oh yeah, that works, okay. So we get y plus 6 and y minus 4 as our factors, awesome. Which means y is going to be equal to 6, or y is going to be equal to 4. Oh, I'm sorry, negative 6. Yep, so negative 6 or 4. Cool. And the very last thing that we're going to do is find our x coordinates. X is, remember, x is 10 minus y. So 10 minus minus 6 is 16. And 10 minus 4 is just 6. So we can say that, you know, for example, since we said a is up here, we can say a is 6, 4, and b is 16, negative 6. Awesome. We're not done yet though, because we still have to find this midpoint here. And what's the formula for a midpoint? So you could just work this out intuitively, which would be slightly easier if you prefer to do it that way, but anyways, the midpoint formula is going to be x1 plus x2 over 2 and y1 plus y2 over 2. So let me just give you a quick explanation of where that comes from. This midpoint here is halfway between a and b in terms of the x coordinates. So it's halfway between a and b, and it's also halfway between a and b in terms of y coordinates. Right here somewhere, so it's right there. So that's the reason we're finding the halfway point with the x1 plus x2 over 2, y1 plus y2 over 2. And if we do that, we'll get 6 plus 16 over 2 and 4 minus 6 over 2, which is of course just going to be 11 and negative 1. And that's it, we're done. So hope that helped you, and yeah, good luck with your revision. I'll see you later.